Good morning, everyone. I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Now, I am moving to tell about the basic definitions of this vector differentiation with some examples. So, here in the vector calculus, we are having the vector differentiation and vector integration. So, here vector differentiation is the fourth module. So, now we are going to discuss about vector differentiation. So in this chapter, vector differential calculus is considered, which extend the basic concepts of differential calculus such as continuity and differentiability to vector functions in a simple and natural way. Also, the new concepts of gradient, divergence, and curl are introduced here. So, what is the vector differentiation? If vector r is a function of a scalar variability, then we can write r bar equal to r bar of t. So, if a particle is moving along a curved path, then the position vector r bar of the particle is a function of t. If the component of f of t along x-axis, y-axis and z-axis. So here along x-axis we are taking I bar, along z-axis we are taking j bar, along z-axis we are taking k bar. So they are f1 of t, f2 of t, f3 of t respectively. So for the x-axis f1 of t with the vector I bar, and y-axis f2 of t with the vector j bar, and here f3 of t with z-axis with the k bar. So based on this we can write f of t equal to fn of t into I bar plus f2 of t into j bar plus f3 of t into k bar. So first of all, before going to the problems, so what are the basic definitions? We should know here what is the scalar point function, what is the vector point function. First of all, what is the point function? A variable quantity whose value at any point in the region of space depends upon the position of the point is called a point function. A variable quantity whose value at any point in a region of space depends upon the position of the point is called the point function. There are two types of point functions. First one is scalar point function. What is a scalar point function? If to each point p of x comma y comma z of a region R in space, their corresponding a unique scalar, that is f of p. Then f is called a scalar point function. For example, here the temperature distribution in a heated body, density of a body, and potential due to gravity are the examples of scalar point functions. So for the scalar point function, there is no direction. So coming to vector point function. If to each point p of x comma y comma z of a region R in space, there corresponds a unique vector, that is f of p, then f is called a vector point function. For example, the velocities of a moving fluid, gravitational force are the examples of vector point function. So next one is vector differential operator. So here vector differential operator we are denoting with del. It is denoted by symbol, this one downward triangle, we will call it as del. It is denoted by del equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So del is, read it as some of the examples about this. So for example, to take the heated solid, at each point P of x comma y comma z of the solid, there will be temperature. The temperature is a scalar point function. Temperature is a scalar point function. Suppose a particle is tracing a path in a space when it occupies a position P of x comma y comma z in a space, it will be having some speed. Say v, the speed is the scalar point function. Next, consider a particle moving in a space at each point P on its path. The particle will be having a velocity. So velocity has some direction. So which is the vector point function. So vector should have the direction that we are denoting with bar here. Bar. Similarly, acceleration of the particle is also a vector point function. Here temperature is scalar point function, speed is scalar point function, and here velocity and acceleration both are vector point functions. And in a magnetic field, at any point P of x comma y comma z, there will be a magnetic force, that is a bar of x comma y comma z. This is called magnetic force field. This is called magnetic force field. This is also an example of vector point function. This is also an example of vector point function. So what is the gradient of a scalar function? See here. If phi of x comma y comma z be a scalar function, then I into dou pi by dou x, j into dou pi by dou y, k into dou pi by dou z is called gradient of a scalar point function. It is denoted by grad pi. So here grad, we can write gradient as grad pi. So what is the formula for the grad pi? Grad pi equal to I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. Here we can write this as a separation. So grad means I dou by dou z, dou by dou x plus j dou by dou y plus k dou by dou z with the function I here. Pi is x comma y comma z. So this grade pi we can denote with del also, that is nothing but del pi. So grad pi means we have to use this formula to calculate the value of the given function. The fluid is compressible. There can be no gain or loss in the volume. So compressible. So then divergence of V is 0. Divergence of V is 0. So what is the divergence? I am going to tell you now. Based on that, we can move for the function here. Next definition. Normal and directional derivative. What is normal? If pi of x comma y comma z equal to c represents a family of surfaces for different values of the constant c. On differentiating pi, we get d pi equal to 0. So here d pi equal to del pi dot dr bar. So del pi dot dr is equal to 0. The scalar product of two vectors del pi and dr bar being 0. So del pi and dr bar are perpendicular to each other. When this dot product is 0, these two are perpendicular to each other. So dr bar is in the direction of tangent to the given surface. So del pi is vector normal to the given surface. When it is perpendicular to each other, based on that we can say that del pi is the vector normal to the pi. Next one, directional derivative. The component of del pi in the direction of a vector d bar is equal to del pi dot dr bar. So E is called directional derivative. What is the directional derivative? Del pi dot dr. Otherwise del pi dot d. Like that we are saying here. So here Dou pi by dou r is nothing but limit del r tends to 0, del pi by del r. So now dou pi by dou r is called the directional limit of pi at p in the direction pq. So here we can see some properties of differential functions. Derivative of a constant vector a bar, derivative of a constant vector a bar, if a bar and b bar are differential vector functions, a bar and b bar are differential vector functions, then d by dt of a bar plus b bar equal to, here plus or minus we are using, so d by dt of a bar plus or minus b bar equal to dA bar by dt plus or minus dB bar by dt. So here dA bar by dt plus dB bar by dt. Otherwise we can write here dA bar by dt minus dB bar by dt. So here we are giving the formula for the both addition and subtraction. So you can see here next one is dot product. So d by dt of a bar dot b bar. So here dA bar by dt dot b bar plus a bar dot dB bar by dt. Next formula is d by dt of a bar cross b bar. You can say this one dA bar by dt cross b bar plus a bar cross dB bar by dt. These are the sum of the properties of differential functions. Some of the properties of differential functions. So, some of the properties of partial differentiation we are going to know. Then we can use this one in the sum of the problems. So, if dou by dou t of pi into a bar equal to, can write dou pi by dou t a bar plus pi into a bar by dou t. So here first we will do partial differentiation for the pi and a bar will as it is. Next pi separated. Now we are doing for the a bar. Next second one is if lambda is a constant, then so dou by dou t of lambda into a bar equal to lambda is a constant taking out. So dou a bar by dou t. Dou a bar by dou t. Next, if c is a constant vector, then dou by dou t of pi c bar. So c bar is a constant. So dou pi by dou t. Next, what you taken before? Same formulas we are observing here. Dou by dou t of a bar plus or minus b bar equal to dou a bar by dou t plus or minus dou b bar by dou t. Next one is dou by dou t of a bar dot b bar equal to dou a bar by dou t dot b bar plus a bar dot dou b bar by dou t. When you are taking cross product here, dou a bar by dou t cross b bar plus a bar cross dou b bar by dou t. So here one more time I am explaining about what is the gradient of a scalar point function. Let y of x comma y comma z be a scalar point function of position defined in some region. Then vector function I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z is known as gradient of pi. This is gradient of pi. That means we can write this one as a grad pi or del pi. So here del pi equal to, what is the del already given in the form? So I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So after that we are going to apply the pi. So that is pi. Now based on this I can write this one is I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. So this is only they given here. Del pi equal to I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. So some of the properties about this gradient of a scalar point function we can observe here. If f and g are two scalar functions, then grad of f plus or minus g equal to grad f plus or minus grad g. Grad f plus or minus grad g. So if they given two functions here, so how we can apply the formula or tool, you can observe here. So grad of f plus or minus g equal to grad f plus or minus grad g. We are separating the function here. So that means grad f plus grad g or grad f minus grad g based on the given property. So next one is the necessary and sufficient condition for a scalar point function to be constant is that del pi, del f or del pi equal to 0. So here the constant should be 0. Next, to now we see about the addition and subtraction. Now we are doing the product here. Grad of fg equal to first f, just we will do for the second function, so grad g plus next one g as it is, we are doing the grad for the f. So here grad of fg as like a differentiation formula, grad fg equal to f grad g plus g grad f. F grad g grad f. Next, if c is constant, so grad of cf. So c is the constant. So grad of c is the constant and one function that is equal to c is the constant taking out grad f. Right? These are the some of the properties about the gradient. So I am going to explain one problem based on this gradient. So here, if pi equal to 3x square y minus y cube z square. So here we are going to find grad pi at the point 1 comma minus 2 comma 1. So here what they are asking to find the grad pi. So first of all, given function, given pi equal to 3x square y minus y cube z square. This is the given function. Here what we have to calculate grad pi. So grad pi means nothing but del pi. So what is the formula for del pi is del is I into 2 by 2x plus j into 2 by 2y plus k into 2 by 2z with the function pi. So here first I am writing this one I 2 by 2x plus j 2 by 2y plus k 2 by 2z. Function is pi is the given function 3x square y minus y cube z square. 3x square y minus y cube z square. So that way according to the formula, what is the formula? I 2 pi by 2x plus j 2 pi by 2y plus k 2 pi by 2z. So I need to calculate 2 pi by 2x, 2 pi by 2y, 2 pi by 2z. Then I can replace in the formula. So that's why first I am calculating what is the pi here. Pi equal to 3x square y minus y cube z square. So here what is the 2 pi by 2x? 2 pi by 2x equal to, with respect to x I am doing. So 3y constant. So partial differentiation of x square is 2x minus. Here y cube and z square there is no other function, so this is 0. So finally I got this is 6xy. That is only here. I into 6xy. Now I'm going to do 2 pi by 2 pi by 2y. What is the 2 pi by 2y? 3x square is the constant, y is 1 minus z square is taking as constant here. So y cube, that means 3y square. So what is the value here? 3x square minus 3y square z square. That is the value. It is 3x square minus 3y square z square. Now 2 pi by 2z. What is the 2 pi by 2z value? Here 2 pi by 2z equal to here 3x square y square. All terms are constant. There is no z term, so 0 minus here z term is there y square, so y cube is the constant. So z square is 2z. Finally, this value is minus 2y cubed z. That is what will be written here. So this is the 2 pi by 2x value. This is 2 pi by 2 value. This is the 2 pi by 2z value. Now, after calculating grad pi, so I calculated grad pi. This is the grad pi value. Now, what they're asking at the point 1 comma minus 2 comma 1. So, what is at the point? At the point 1 comma minus 2 comma 1. That means x value is 1, y value is minus 2, z value is 1. So, here I got del pi equal to I into 6xy plus j into 3x square minus 3y square z square plus k into minus 2y cubed z. So here we are going to replace x equal to 1, y equal to 2, z equal to 1. So based on that, I into 6, x value is 1, y value is minus 2. So this is minus 12i, this is minus 12y, that is the first term. Next, plus j into 3 into 1 square minus 3 into y value is minus 2 whole square, z is 1. So finally this is 3 plus 12. So finally here we got 3 plus 3 minus 12. So what is the plus 3 minus 12? 9j. So this is the next value. So next plus k into here minus 2. Next y cube is minus 2 whole cube. Next z is 1. Now minus 2 into minus 2 whole cube. So minus 2 whole cube is minus 8. So minus 2 into minus 8. So here minus 1. So finally we got here. So this is the grad pi at the point 1 comma minus 2 comma 1 minus 12y minus 9j minus 6k. So if they're asking up to the only del pi, this is enough. Up to this step is enough. Just we are calculating 2 pi by 2x, 2 pi by 2y and 2 pi by 2z. So if they're asking at the point, means we have to substitute the x, y and z values in the above function, grad pi function, then we can get the value like this. So grad pi at 1 comma minus 2 comma 1 equal to minus 12y minus 9 minus 16k. So this is the way to calculate the given problem by using the grad pi formula at the point. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.